Hello everyone, welcome to our setup programming course. Okay, today we're going to learn some basic estimation of CAPM, the capital asset pricing model. So in this week we'll have two parts. The first part is to introduce the concept and how to run a simple ROS regression with Stata to estimate CAPM. And in the second part, we'll learn how to run the CAPM regression when there are lots of company observations in our data sets. And the key point is about how to use loops to help us make things clean and simple and fast to run the CAPM regression altogether when there are many, especially when there are hundreds and thousands of firms. Okay, so first of all, please open your Stata system, and also open the Stata do file editor with the codes of Stata for today's course. So in the first part, we're going to estimate the CAPM model using a simple ROS regression. So the first step is to import the data set. And in the CBA website, I give you some files to practice with. So among them, there's one called CAPM, which is in Excel format. So in order to, in addition to import this Excel file with the Stata codes, we can also import the Excel file manually. Okay, so select the one that we're going to use and click on import first row as the variable names. And after that, we will successfully import the dataset here. And my preference is to set the working directly first, because in the remaining parts we no longer need to make any changes where we're going to saving the data sets. For example, we're going to save this CAPM data sets into another one, which is stored in the Stata DTA format. So we can just type save and file name and replace. Okay, so after importing the data, then we can get a quick view of what this data set look like. So you can see that the first column contains the time series information, which is the date column. And actually you see that the date column is actually in the daily date format. For example, for the third observation, the date is 2002 March 1st, and for the next observation is April 1st in 2002. And after you roll down rows, you can see that actually the sample period is during 2002 to April 1st, 2013. Okay, and the next column to the remaining columns are actually the stock price and interest rate information to estimate the CAPM. The second column is the index price information for S&P 500 index. And the next several columns are the stock price information for 4 USA companies. For example, the Ford is for the Ford company, and the GE is for General Motors, and Microsoft and the company Oracle. And the last column is actually the information for the USA 3-month T-bill rate, which is for serving as the risk-free interest rate in estimating the CAPM model. Okay, so after we have this information, then we can start our estimation. First of all, in order to run the CAPM regression, we need some information. First of all, we need the return information and also the excess return information. And after that, we can run the simple ROS, right? So in order to that, remember that we still do not have any return information in this dataset. So we need to calculate the returns by ourselves. In order to do that, we will use the concept of the log return to calculate the continuously compounded returns from the raw data in our data set. So we'll use the log function to calculate the continuously compounded returns in the log expression. And also, in calculating the compounded returns, we may use the concept of lagging, which is referring to the previous one period of the variable. So in order to take the lags information, the one previous one information of the variable, then we need to tell Stata the specific time information contained in these data sets. And in order to do that, we first need to change the data type from daily to monthly that is readable to Stata, and tell Stata that this data set is recorded in the monthly day series. Okay, so to do that, we'll use two lines of code. For the first one is to replace the original date variable with the new day series, which is modified by this command mofd in parentheses dates. And then type formats dates into %tn to change the original daily date information into monthly date information. Okay, so after that, you'll see that has changed the date information into monthly series for us. For example, for the first observations, because originally it's in January 1st, 2002, right? So in order to transform it into the monthly series, Stata will transform it into 2002 M1, which represents January of 2002 for us. So another example is the fourth observation, which is originally April 1st, 2002. So after transformation, it will become April 2002, which is 2002 M4 here in Stata. Okay, so after that, we can do the remaining process. Okay, so in order to calculate the continuously compounded returns, we need another step to tell Stata that the time variable is actually the column called date in this data set. So we need another command called tsset, which is actually the meaning time series setting. We use the time series setting to tell Stata that the date column in this data set is the time variable. Okay, to indicate that this data set has a time series format. And after setting the TSH date, we'll see that Stata has shown and has recognized that this data set is a time series format, and the time variable is dates ranging from January 2002 to April 2013. And the gap is 1 month because this data set is stored in the monthly series. Okay, so after that, we can start to calculate the continuously compounded returns with the log transformation. Okay, so first of all, we need to calculate the compounded returns of the S&P 500 index. So in order to do that, we'll first divide S&P by the lag 1 period of S&P, and then take log, and then multiply the log return by 100 to adjust the unit. Okay, and Stata will generate a new variable, which is the continuously compounded returns expressed in percentage units. Okay, and for the remaining, we can also do the same things to transform this stock price information into the continuously compounded returns information. Okay, then after we have we have got the continuously compounded returns, we need the excess returns to put into the CAPM model, right? So in order to do that, we can just do some basic calculation. That is to subtract the risk-free interest rate from the original company returns that we have just calculated. And here, because the risk-free interest rate we're using is the US 3-month T-bill rate, which is actually the annualized formats from the original raw data here. So in order to transform it into the monthly series, we need to divide this original variable of USTB3N by 12 to make it the monthly units of the T-bill rate. Okay, so after that we'll get the correct units of the 3-month T-bill rate. Okay, then we can just calculate simply the excess returns for these stocks. For example, for the S&P 500, we use another variable name called ERSANDP to represent the excess returns of S&P 500. And we just type the formula RSANDP, which is the continuously compounded returns, and then minus USTB 3-month, the monthly units 3-month T-bill rate. Okay, so the remaining stock price information, we can also do the same thing to calculate the excess returns. Okay, so after the calculations, before we're going to do the OLS regression, we can get a quick look of the simple relation between the two variables. For example, we want to know the market return, the S&P 500, and their relation with some company stocks return. For example, we want to see if there a strong relation between the S&P 500, the market return, and the company stock return, the Ford in excess return. Okay, so here there are two ways to get their correlation. The first one is called TSR line in Stata, which plots the time series of these two variables. So from this graph, we can see actually the two stock returns fluctuates very closely together. When the S&P 500 goes up, then actually the stock returns of the Ford company will also goes up. Okay, and another plot is the scatter plot, which will show us a more clear view of the relation between S&P 500 and the excess returns of the Ford company. We see that there is actually maybe positive relation between the two. Okay, so after the quick view by plotting the graphs, we can start to run the simple OLS to estimate the CAPM model. Okay, so because now we have 4 companies here to estimate the CAPM model, and we have 1 CAPM for 1 company. So in order to do that, we'll use a simple loop called for each loop. So remember in the last week's course, we have demonstrated how to use the for each loop. So in application here, we can just type for each x to represent the variable x in the following list of the variable, the 4 excess returns of the companies. Okay, we could just type them there and type the main regression command reg and then x in this special signature here to indicate that we're running a loop with the variable name in called x here, and then the excess return of S&P 500 to use it as the market return in our CAPM model. So after that, we can quickly run for regression in the CAPM, and here are the results. Okay, so for the results, we can see that in the OLS, we'll have the results, the coefficients for the constant terms. So in the CAPM, the constant terms is actually the alpha, the intercepts in the CAPM model. And the coefficient for the market index, the excess return of the S&P, is actually the beta in our CAPM model, which represents the sensitivity that the returns of the company to the returns to the market index. Okay, so until now we have demonstrated how to estimate the CAPM model with simple ROS with Stata. And in the next part, we're going to learn how to estimate the CAPM with ROS when there are maybe hundreds or thousands or even millions of firms in our data sets, and how to do that with some set of looping together. And let us take a break.